Scientific notation. The objective of this lesson is to write numbers using scientific notation. The scientific notation of a number is written in the form c times 10 to the nth power, where c is either equal to 1 or greater than 1, but less than 10. Okay, how do we change from standard form to scientific notation? If we're given the number, a very big number, such as 120 million, then we need to shift the decimal to the left. Therefore, we need to move 8 decimal places to the left, right before the non-zero digit 1. Okay, that's where we stop. 1.2 times 100 million will be the product form. And because we have 8 zeros, or we shifted 8 places to the left, we therefore multiply by 10 to the 8th power. Okay, and this is our scientific notation. So our rule is you move the decimal point to the left when you're given such a big number. And then you use the positive exponent for the number of places moved. Okay? And if you're given a very small number or decimal number, such as 0.0012, we want to move the decimal towards the non-zero digits. So, and stop right after the first non-zero digit, Okay? So, you end up with 1.2 times 0.0001. So that's 4 decimal places to the right. And therefore, when we write the scientific notation, we need to multiply 1.2 by 10 to the negative 4th power. Okay, so our rule is you got to move the decimal point to the right when you're given such a small decimal number, and then use a negative exponent for the number of places moved. Okay, let's do some practice problems. Write the number in scientific notation. Alright. You're given a very big number here, so you know the decimal point is at the end of the number. And you need to shift your decimal until you get to 3, right before 3. Okay? 3.46 times 10 to the 7th power, where 7 represents the number of places shifted. 1, 2, 3, 4, 5, 6, 7. Okay? And then now you're given a very small decimal number. So we need to move the decimal point towards the right, because that's our goal. We want to put the decimal right after the first non-zero digit. 1.45, and how many places did we shift? 1, 2, 3, 4, 5. Okay, that's 10 to the negative 5 power, and negative 5. The 5 here, represents the number of places shifted. Okay, and let me do 51,000 first. Again, we got a big number here, so our decimal point is at the end of the number. So we would have to shift to the left, so it'll be 5.1 times 10 to the 4th power. And for this one, we got to shift to the right. 6.798 times how many places? 1, 2, 3, 4, 5. So that would be 10 to the negative 5th power. Okay? Okay, so what if I give you a problem like the one here? 1.3 times 10 to the 4th power and 13 times 10 to the 2nd power. So we need to first multiply 1.3 and 13, which is 16.9. And then we got to multiply these two factors here. So that would give us times 10 to the 6th power. Alright, and then we need to shift 1 decimal place to the left because we want the decimal right before the first non-zero digit. Okay, so that would be 1.69 times 10 to the 1st power because of this shift times 10 to the 6th. I'm just bringing this right down. And by the product property, we just add 1 and 6 to get 7. Okay, so this is our answer. Right, let me do the next one. Okay, so now we have 0.014 and 14, and that will give us 0.196 and times 10 to the 4th power and times 10 to the negative 7th power, which will give us 10 to the negative 3rd power because 4 plus negative 7 is negative 3. Again, we need to shift this decimal to the right 1 place because we want that decimal to land right after the first non-zero digit. Okay, so because we did that, we need to multiply by 10 to the negative 1 power. Okay, this rule right up here. All right, and then we need to multiply by 10 to the negative 3rd. I just brought that down. And our final answer is 1.96 times 10 to the negative 4th power. Okay. Okay, now we want to order the numbers from least to greatest using scientific notation. Okay, 3.9 times 10 to the 6th is already in scientific notation, so I'm just going to write this here. Okay, I like to list my numbers vertically so I can see it better. And this in scientific notation will be 3.8 times 10 to the 6th power, and this is already in scientific notation. So the smallest one would be this one, and then this one, and then this one. I'm going to write my answer. 4.2 times 10 to the 5th power, and 3.8 times 10 to the 6th power, 3.9 times 10 to the 6th power, and that's our answer. Okay, and let's do some more practice. Yeah, I'm going to run the first one is already in scientific notation, so I'm going to write it down here. And the second one is 1.7 times 10 to the negative 4. The third one is already in scientific notation. Okay, let's take a look at which one's the smallest one. So it seems like the smallest one would be this one, and then the first one, and then the third one. Okay, and the smallest one, 1.7 times 10 to the negative 4th power, and the second biggest would be 1.9 times 10 to the negative 4th power, and then we got our smallest one. Okay, now that we learned how to change from the standard form to the scientific notation, we have to learn how to switch it back. Okay, so from scientific notation to standard form, all you have to do is multiply by 10 to the negative 7th power here, for example. So using this decimal point, okay, so we have a decimal point here. We got to shift, all right, 7 places to the right until we get to the end. Okay, 32 million. And to change 8.69 times 10 to the negative 5 back to the standard form, you got to take this power here, okay, it's a 5, and the negative tells us that we need to shift to the left, okay, and 5 places. 1, 2, 3, 4, 5. So 0.0000869 would be our standard form. Okay, and let's take a look at some practice problems. (3.641) times 10 to the negative 6 power. Okay, I have a negative power, so I know I need to shift to the left. Okay, so I'm going to write 3641 here. I'm going to shift 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. So 0.00003641. So your decimal point was right here. And here we have a positive power, so we need to shift to the right. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so sorry about this. Why don't I use a different color? 5, 9, 0, 0, 0, 0, 0, 0. So let's double check. 1, 2, 3, 4, 5, 6, 7, 8. Yes. Okay, so that's our answer. And here we have a negative 3 power, so we need to shift to the left. Write this down. I'm going to use a different color now. 1, 2, 3. Okay. Oh, let me draw an arrow here so you can see. Okay, so 1, 2, 3. Alright, that's our answer. And we got a positive power, so we got to shift to the right. 7. Decimal starts here. 1, 2, 3, 4. 1, 2, 3, 4. And that's our answer. 70,000. Okay. That's it.